Okay, this is the second time I've had to have a go at this because I've misread the question each other time. So this is question 1 from activity 7D. So two astronauts, A and B, are separated by a different distance of 15 meters, and we've been asked to find the center of mass. A weighs 90, B weighs 110. So part A says find the center of mass. We're going to use this distance here. We're going to call it D. So we're going to use the torque balance approach here because of where the center of mass is between the two objects. So MA times D equals MB times 110 minus D. 90D equals not 110, 15 equals 1650 minus 110D. The mass B here is 110. 200D equals 1650. D equals 8.25 meters, or 8.3 meters to two significant figures. Now we want to keep this one because we're going to use it further on. Part B1. A starts to reel on the rope at her end. After 8.5, she's reduced the length of the rope by 5.5. What distance does the center of mass move in this time? So relative to space, the center of mass does not move because the only force acting is inside the system. So only an internal force is acting, not any external force. 2, calculate the new distance of the center of mass from A. Well, we can just do the same calc again, except with a different distance. Let's move 5.5, so now 9.5 meters apart. So MA times the new D, call it D dash, equals MB times 9.5 minus D dash. Alright, so we get 90 D dash equals 9.5 times 110. 1045 minus 110 D dash. 200 D dash equals 1045, or D dash equals 5.225 equals 5.2 meters to two significant figures. So that's 5.2 meters from A. Alright, part 3. Now it says calculate the velocity of A. Now the key is this actually combines this and this. So the center of mass has not moved. So that means that the distance from A shrinking from 8.3 to 5.2 is entirely due to the movement of A. So delta D is entirely from movement of A, therefore VA equals delta D over delta T equals 8.25 minus 5.225 divided by, took her how many seconds? 8.5 seconds. We do that calculation. We get 0.356 or 0.36 to two significant figures, and it's meters per second. Never forget the unit. And what about velocity of B? Okay, so we're going to do the same thing. if the distance is now 5.2, so the distance, so basically what was D's position relative to the center of mass. So in this case, CM not moved. So distance, so I call it dB was, or dB initial equals 15 minus 8.3. dB final equals 9.5 minus 5. It's actually not, I want to use 2.5, don't I? 5.225, and VB equals the difference between those. So 9.5, I'm going to do those calcs as I do this. So 9.5 minus 5.225, so 4.275 minus 6.75 all over, and we need the time. Time is, what was it, 8.5 seconds. And we get 0.291 or 0.29 meters per second to two significant figures. To my usual, we'll just have a quick check. Yep. All right, so the core to that one was the idea that the center of mass was not moving. Just clear the frame and then put a nice big 2 up here. So, question 2. The diagram has two trolleys, one before the collision and after the collision. The two trolleys are said to be identical trolleys. So this is a key idea. They're labelled trolleys. They're not labelled at all. So they're identical trolleys. Why is that important? Because that means that masses are the same. All right, part A. What is the velocity of the center of mass of the system of the two trolleys? Well, the core idea here is that absent external force, there is no change in velocity. What's that from? Newton's first law. So in the absence of a net external force, there's no change in velocity. So the center of mass, so Vcom before equals the velocity of the center of mass after. Therefore, Vcom equals 1.4 meters per second, which is the piece of information we're given, that after the collision, they're moving with a velocity of 1.4 meters per second. What about V? In relation to the individual positions of the two trolleys, explain where the center of mass of the system will be. Well, the key idea here is the masses are the same. Because the trolleys have same mass, the center of mass will always be midway between the trolleys. And we can put a formula in here if we want. We could use the, capital M, capital X equals little m, little x. But M equals M, therefore capital X equals little x if we want. Just tells us the distance from the centre of mass to each of the two masses is the same. Alright, C1. 1 second after the collision, the centre of the mass of the system will be 1.4 meters from the collision point. Yep. Explain how far the centre of mass will be from the collision point 1 second before the trolleys collide. Well, not where it will be, where it was. Well, the velocity of the COM is constant because of no external force. Therefore, 1 second before collision, it was 1.4 meters to the left. And calculate the velocity of the moving trolley before the collision. Well, the COM was halfway between the trolleys, and refer to answer B. Therefore, trolley moving was 2.8 meters from stationary trolley, because that would put the centre of mass halfway between the two, or at a location 1.4 meters from the stationary trolley. No, of course that's not what it asked me, so I better go back and actually fix that. Yeah, they didn't ask that, did they? They asked something else. They asked for what's the velocity. So it shows you how important it is to really carefully read the question. I was thinking where was the position of the left-hand trolley. That's not what it asked at all. It was asking what the velocity was. The velocity of the moving trolley before the collision. Well, okay. So P before, so this is a momentum aspect. Momentum before equals momentum after. Now, momentum equals mv. So the momentum after, in this case, we'll just assume we'll give the mass of a trolley to be capital M. Capital M, and there's two of those trolleys, so that's twice of that, and then times 1.4. Now, mass, so that's our momentum after. Momentum before equals, well, there's only one trolley moving before the collision, so it's big capital M, times our velocity that's unknown, and we know that from P before equals P after equals our after. Here's our after, so we substitute that in here. M times 2 times 1.4, and so now we've got this equation here. M times V, or capital M times V equals capital M times 2 times 1.4. We've got divide both sides by M. Let's just break this off from here for now. So divide both sides by M, and we get V equals 2 times 1.4, which we can work out as 2.8 meters per second. To two significant figures. Okay, so that's better. I think I answered the right question this time. And having worked it out, I'll now go to check on the answers just to make sure. Yep, that's what, and you know, this is the reason it's good to do these, but don't go checking the answers until you've had a really good go at it, and then when you spot that you've done something wrong, go back and do it again until you get the right answer. Okay, question 3. The diagram, it's a big booty diagram. It's got two pucks, two positions. I'm assuming you've got the diagram in front of you. So the first thing it wants us to do is work out at the first instant, give the coordinates of the centre of mass of the two pucks. Well, to start with, we need the coordinates of each of the pucks. So for A, the coordinates are at x equals 5 and y equals 35. For puck B, the coordinates are, this is A1, B1, 5, 5. And so the center of mass, that's going to be, and what do we know? We know that mass A equals 0.2 kilograms and mass B equals 0.1 kilograms. Now maybe we've done this enough to do it by intuition. The total mass is 0.3. Mass A has 2/3 of the total mass, so and mass B has 1/3 of the total mass. So the center of mass will be 1/3 of the way from puck A to puck B, or maybe we need to do the balances. Now clearly here on the x-axis they're in the same location, so we could just do it based on the y and use the 35 and the 5. There are lots of possible ways to do this. I'm going to go distance from A. So what have we got? We've got mass A times D equals mass B times, in this case, the difference between the two is 30. 30 minus D. Just looking at the y values only. And so we get MA times D equals MB times 30 minus D. What am I solving for? Of course, yep. So 0.2 times D equals 0.1 times 30 is 3 minus 0.1 times D, 0.3, D equals 3, D equals 1. I don't think that's right. What have I done wrong? If I divide by If I divide 3 by 0.3, I don't get 1, do I? 3 divided by 0.3. And if I do this properly and write it out, then it makes it obvious to me that I get 10. Right, and so the distance from A is 10. That means it's 10, or it's 1/3 of the way between A1 and B1, which is what I started with. Therefore, the center of mass is at 5,25. Okay. Part B. Sometime after collision, puck B is at position B3. At this instant, give the coordinates of 1, the center of mass. So to work this out, we really need to know what is the velocity of the center of mass. So we call it VCOM equals question mark. We need to know that. That's our goal. Well, to work out the velocity of something, we can use 2 positions in a time. And we've been given 2 positions. Well, more importantly, puck A has a mass of 0.2, blah, 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 blah. Point O is collision point puck A. It's interesting because it's got these A2 and A and B2 positions, but it hasn't actually given us much in the way of a time between them. Was it supposed to? Oh, maybe it doesn't matter. First we'll work out the velocity. So we'll work out the direction of the velocity. That'll give us the path of the puck. And that might help us solve this problem. So let's have a look. So the velocity of the center of mass, well, let's have a look at point A2, B2, and that'll give us some starting point. So the center of mass at location 2, this is center of mass at location 1. We're going to do the same thing as we did up above. So we need A2, and A2 is at at 1530. and B2 is at 15, 20, 15, 15. So the centre of mass, again, we're at the same X position, and the Y positions are now 15 apart, so we're 2/3 of the way from B2 to A2, which gives us 15, 25 as the centre of mass 2. Now that means that if we now look at these 2 points, it's tracked from 525 to 1525 as it moves from time instant 1 to time instant 2. So the path is horizontal. So it's completely in the X direction. Okay. Now that means that no matter what, the center of mass, no matter what, the path of the center of mass is in this X direction. And so we should see that, and we should see that apply to where the collision point is, which is true. The collision point is at location at this 25 line on the y-axis. It's at 25, 25, 25, okay? And yeah, so we know that at least, and it means that the center of mass will keep on tracking along the same 25 line. So if that's true, if we know that the center of mass tracks along the 25 line, then I think we also know that this puck B3, that this puck at B3 is going to match that nicely. Let me just do a bit of quick recon on this first.